Hi folks, Mr. Long here. We're going to do a screencast on the product rule doing derivatives without algebra. Okay, so we're going to be doing derivatives without any algebra. And here's what we mean. So the scenario that we've got here is that, so we've got y equals f, a function f multiplied by a function g. And what we want to do is get the value of the derivative when x equals 1. What's y prime at 1? So if y is defined as f multiplied by g. And the way we do it is we're given a whole bunch of information in a table of values here. So we don't actually have algebraic functions. What we have to do is look at values on here. So for example, we want to get y prime at 1. Well, clearly we're going to have to end up at some point getting f prime at 1 and getting g prime at 1. We're also going to need f at 1 and g at 1, right? So here's the product rule. A prime b plus a b prime. That's the product rule, right? So in this case, instead of a and b, we've got f and g. So we've got f and g. So we've got f and we've got g. So f is going to be the first one. So it's going to be f prime g plus fg prime. And the thing that we need to be aware of is that we're going to have to be substituting in 1. So let's look at what the first line would look like for this. So as we know, it's a prime b plus a b prime. Okay, so for us, again, that's a and that's b. F is a and g is b. So instead of just f prime, though, we want to get what's the tangent slope when x equals 1. So we have to replace our x's with 1, right? We can go directly to that point because we don't have an algebraic function. So it becomes f prime at 1 multiplied by g of 1 plus f of 1 times g prime of 1. Well, how do we figure those out? They're given in this table down here. So we're going to be using the values for 1. Okay, we're going to be using these values right in that area there. Okay, so so let's see. We're going to be using, I'm just going to do a highlight over top of this. So we're going to be working with x equals 1 to begin. So what's f prime at 1? So I go to x equals 1 and I go down until I see f prime. F prime is over here. So I've got f prime at 1, or sorry, f prime at x equals 1 is 1. Then I've got g of 1. Well, g of 1 is, and well, actually, let's just go through it and see. Okay, let's go through it and see. So what do we end up getting? So we need to have f prime at 1 is 1, then g of 1. So I go to x equals 1, the x value is 1, and then I go to the g function. G at 1 is 9, and that's hence why I use 9 there. Okay, moving across, I'm going to have my plus sign, and then I have f at 1. So now again, I go to x equals 1 in the table, and I go to f at x, and it's worth 3. Okay, then I keep going, and g prime when x equals 1. So x equals 1, and I go down to g prime, and it's 5. Okay, so that, folks, is our product rule by substituting in 1. 1 times 9 is 9, 3 times 5 is 15, 9 plus 15 is 24. Okay, so we know what the value of the derivative is. So the tangent slope at x equals 1 is 24 for this function. Notice we didn't use any algebra because the data was given in a table of values. Okay, so same process again. This time, though, y equals g multiplied by h, and we're going to find y prime at 3. So this time we actually have to use this graph here, h of x. Okay, so instead of just using a table, we're also going to use h of x. So what are we going to be doing here? We're going to be finding out y prime at 3. Okay, we're going to be finding out y prime at 3. And so, again, it's the a part is going to be g, the b part will be h. A times b, g times h. A prime b is g prime at 3 multiplied by h at 3. Then we have g at 3 multiplied by h prime at 3. Okay, and that's b So a prime b plus ab prime. Okay, we're figuring out the tangent slope where x equals 3. So we've got that one. Now let's start substituting values in. So I need to find g prime at 3. So I go to my g function. G is right here, and x equals 3. So I go down until x equals 3, and I look at g prime. It looks like the answer should be 9. Okay, so that's correct. H at 3. H at 3. So I'm going to go, oh, H is this graph over here. Okay, H is this graph over here. And I only have a segment of the graph showing because I couldn't quite fit everything, but just know that this is x equals 3, this is x equals 4, this is x equals 5, and so on. So we need to find out H at 3. So we go to x equals 3, we're on the graph of H, and I go up until I hit that point, and I go across, and it's also 9. So H at 3 is 9. Plus, so it's a prime b plus a b prime. Now I have to do g at 3. So I'm substituting x equals 3 into the function g. And instead of having equations, I just have these tables in this graph. So I need to do g at 3. So I go to x equals 3. I'll highlight this one here. And I go down until I get to g. So there's g right there. G at 3 is equal to 7. Okay, so I look at that, that's 7. Next, I need to do h prime at 3. H is the graphical function. So look at this. There's x equals 3. And what I have to do is I have to go, whoops. I've got to go to this point here. Okay, so x equals 3 on h of x. Well, what's h prime worth there? Can I tell what h prime is worth? That's a corner. Does the function have local linearity there? No. So what's true about that derivative? That derivative does not exist because it's at a corner, right? There's no local linearity. So can I even calculate the derivative using the product rule? No. The derivative does not exist because h prime at 3 does not exist. I could get a derivative anywhere on here because it's a nice smooth curve. Here the same. So like at x equals 4, the tangent slope would be 0. At x equals, let's see, that's 6 and that's 7. So at x equals 7, there's definitely a tangent slope that's -1, rise over run. So it appears that we don't have a tangent slope there, so it does not exist. Okay, so that's how you do the product rule when you're doing derivatives without algebra.